Welcome everyone to 2025. Uh, the very beginning here in January of Mesa International's series of webinars. We're going to be doing quite a few this year, and really trying to reach both our membership and overall manufacturing and operations audiences with regard to topics that are very important for Mesa and very important for industry in general. This webinar in particular, today's webinar, is talking about a Foundation for Digital Transformation, MES. MESA, which stands for Manufacturing Enterprise Solution Association, that's the current acronym, was at one time the Manufacturing Enterprise Systems or Execution System Association. Maybe back in the day, in the 90s, back when MES was really the foundation for digital transformation. It still is, and that's really the basis of this webinar today. I'll be your moderator. My name is Chris Monchinsky. I lead up the MESA Knowledge Committee. The Knowledge Committee is really responsible for generating, curating, and publishing the content that is so important to our MESA membership. That includes webinars like today, our podcast, but it also includes white papers, ROI documents, and research and information such as the upcoming research that we do every other year on the application of analytics and AI in manufacturing. And that's going to be coming and being published shortly this spring in 2025. For anyone who might not already know, MESA is a nonprofit association. We've been around since 1992, since the early days of MES, before the term digital transformation was a thing. Um, but the things that we do and represent in MESA are the core and foundation of digital transformation. In fact, I'd like to think that our association has been at the forefront of these technologies and the application of these technologies for all the goals that we seek today in digital transformation and smart manufacturing, long before these trends had terms and were significant the way they are today. It is a non-commercial professional organization driven by our members. So membership is key. If you're not a member yet, I would encourage you to become a member at MESA. And it's not just about the content that you can consume at MESA, but it's about having your own voice heard, because MESA is about all of our members and the contributions that each of our members can make towards the greater collective of knowledge that drives our industry forward for best practices and applications of technologies today. So in this webinar, it's a Zoom-based webinar, you'll notice that you have a toolbar up top. At least it starts out up top, but it may be in another location on your system now. But you'll see on audio settings, there's a section here for chat. You can raise your hand, and you can also enter Q&A. Q&A is the key piece for us. What I would ask is although you'll raise hands, I don't expect our presenter to really stop in the middle of the presentation. He's going to take his time in order to present the information that he's going to bring to you today. And then at the end, if you can post your questions in the Q&A, we'll take those questions, and I will ask the question, and then John Clemens, who's with us today and presenting for us, will be happy to answer them. With that, I'd like to introduce John Clemens. John Clemens works for Rockwell Automation, a longtime key sponsor of MESA International. He is going to help us come back to the basics and understand why MES is the core and the foundation for digital transformation. And with that, I'm going to stop sharing, and I'm going to ask you, John, to begin your presentation.
All right. Thank you very much, Chris. I appreciate it. Let me share my screen here. Press the right buttons. So
Perfect.
there we go. All right. Excellent. So hello, everybody. Good morning, good afternoon, good evening, depending on where you are in the world. We sure appreciate you being part of this webinar today. Thank you so much for your time. I want to let you know that everybody will have access to this recording. So if you can't stay the whole time, or you have some other people that need to see it, we are making a recording, and since you registered, you'll get access to it, and you'll also get access to all of these slides that I'm presenting here, because I'm not going to try to read all of them to you. I'm just going to hit a few highlights and then let you get copies of the slides for you to digest in your own time. So again, I'm John Clemens. I'm chairman of the MESA International Americas Board of Directors, and I'm talking about MES, a foundation for digital transformation. As Chris mentioned, I work for Rockwell Automation, and I've been around MES, doing MES kind of stuff for a long time. So hopefully we'll see a little of that history today. So I'd like to start out by just asking the question, what is MES? What is Manufacturing Execution Systems here? This is the original Mesa model that we developed. That was one of the first things that we at Mesa did. And, I was one of the guys that helped put this model together back in the early 90s, where we defined what MES was all about in terms of the different functions and the different interfaces. So you're probably very familiar with this model of understanding what MES is all about. Um, to get into a little more detail about what MES looks like today, it's all about order execution, typically getting orders from ERP, executing those orders on the shop floor, performing traceability, track and trace, providing records of everything that happens on the shop floor, providing work instructions to the people on the shop floor, performing quality checks or quality execution, managing recipes, bills of materials, interfacing to the shop floor, looking at performance in terms of metrics and KPIs, and then providing visibility into what's going on the shop floor. So that's kind of what MES is all about. So some of the questions that MES answers is, if I'm on the shop floor, what am I supposed to be doing right now? What order is supposed to be running? What order is supposed to be next? What's my bill of material? What recipe? Give me the work instructions that I'm supposed to be performing. If I'm sitting here on the shop floor like this guy is with my hands on the keyboard, I want to be able to see all this information. I want to see my work instructions, my quality checks, my bill of materials, my recipes, my orders. That's what MES is all about. MES serves all that up to the operator. Likewise, MES also answers some questions for management. Things like, hey, what materials did you actually use? Where did this raw material come from? Where did it go? Clients calling us up, customers calling us up. Hey, what's the status of this order? Or hey, how is our OEE doing today? Are we winning the day? Are we winning the hour? Why did this take so long? How was this made? Those kinds of questions. That's what MES is all about on the shop floor. The other way to think of MES is it bridges the gaps between the business systems and the manufacturing world. So everything between the ERP systems on the business side and all of the control systems on the other side, MES bridges the gap. But it also works from the receiving dock to the shipping dock so that essentially everything that goes on in the four walls of the manufacturing plant goes in to MES. That's what MES is all about. Another thing that MES does is it helps you attack the waste streams. What happened to my material? How come I've got downtime? Where's my capacity losses? So, all of these different problems that I may run into, MES gives me the information that I can use to attack those waste streams, attack those losses. Ultimately, MES, though, is not a silver bullet. And I want to emphasize this. So if you don't get anything else out of this whole presentation but this one slide, I think this is key. Okay. It's not a silver bullet. Yes, there's some cool technology. We're going to be talking a lot about some cool technology today, even all the way up to AI that's being integrated with MES. But ultimately, it's about that technology getting information and getting the right information to the right people at the right time so they can use it to run the business. But more than that, the people have to be educated. MES works in environments where you have highly skilled, highly trained, highly motivated people that know that they're running a multi-million dollar manufacturing operation. And MES is just one of the key tools that they use. And then ultimately, they're empowered to make the decisions to do what they need to do when they have the technology, they have the information, they have the education. And it's only that combination of smart technology and smart people that creates the end results. So, what about some of this technology I've been talking about? And that's kind of some cool stuff. So one thing about MES today, which is a lot different than it was a number of years ago, is that MES is highly mobile. MES applications now are run on smartphones, they're run on tablets, they're run on pads. Everything is run off a smartphone or an iPad. So you have screens that look like this, you have devices that look like this, you have devices that look like this, screens that look like this. MES is highly mobile. That's the one key part of the technology. Another key part of the technology is the interface to the shop floor. Typically, interfacing the shop floor is normally just kind of a mess with lots and lots of individual tags that you're trying to access to get data from the shop floor because it resides, I don't know, in a bunch of different PLCs, maybe in historians, maybe in distributed control systems, maybe in whatever. But the latest technology uses the idea of smart objects. So you have an object oriented approach to data. So you have data blocks and data objects, and you have this object oriented approach. So all the objects look the same, all the data looks the same, is organized and structured the same using this object oriented approach to the point where adding in more information, more equipment, more data, whatever is a piece of cake because it's all based on this object and this idea of these smart objects on the shop floor. Another thing that I think is key to the success of the MES is the track and trace database. And everybody understands track and trace, but they normally think of it as being we're just doing lot tracking, lot tracing. You know, I got to get all the lot numbers. I got to know that lot A went into lot B, went into lot C, and I get a lot tree as my result, so I can do forward and backward tracing of the lots. But that's not really what MES is all about anymore. What MES is about is capturing everything that goes on in the four walls of the manufacturing plant and getting it into the database. The ultimate litmus test for whether MES has the data or not is when a client or a customer calls up and says, "Hey, I'm having a problem with this product that you gave me. Okay, can you go back to this database and look at every single thing that happened to that product that may have contributed to the problem that your customer is having with it? Okay, do you know who was working on it? What equipment they were working on? What the quality results were that was there? What deviations that might have occurred? Non-conformances that might have happened? What maintenance might have been performed on that piece of equipment before you did that run, or what else was going on in that room at the same time. Okay, all of these kinds of things go into the database so you have a complete picture of everything that happened in manufacturing before, during, and after that product was manufactured. So when that customer calls up and says, "Hey, I got a problem here with your product," you can go back to this database and see everything you need to figure out exactly what happened to that product. And that's what MES is all about. Another thing that MES has done is it has embraced the idea of the industrial Internet of Things. I think everybody understands the IoT. I mean, we love the IoT. I love this picture of this house here with the Internet of Things. I mean, I've got everything from automated lighting to solar energy and everything. This isn't quite my house, although I've got most of this stuff, the irrigation, the electric car, security, lighting, I just don't have the solar energy hooked up yet. Maybe I need to go get that next. But that's really cool and we love it. Well, the industrial Internet of Things, the IoT is just like that. And the IoT and MES are becoming integrated to the point where for modern implementations, you can't really tell the difference. For example, let's look at some screenshots here that's showing this is information from several different regions and several different sites. Okay, I can drill down and look at individual sites and details about what's going on at that individual site. So I can see all of this data being collected by the IoT. All right. I can look at individual details and look at some of the sources of this data. I've got MES data, I've got ERP data, I've got PLM data, I've got CMMS data, I've got historian data, I've got PLC data, and it's all right here on these screens, all because of what the IoT can do. I can even drive deeper and look at an individual asset, which highlights again all of the data, including even the maintenance data from CMMS that's here. But more than that, I can start looking at orders, which is from the ERP. And here's MES to execute these orders. So I can look at these orders. I can look at the due dates, the priorities. So, at what point are we migrating from MES to IoT? It's really the same kind of solution. It's the same piece of this. And so I'm looking at a work cell where I've got my orders. I'm looking at the details of my work orders, and I'm looking at my individual process. You think of these as my steps 10, 20, 30, 40, 50, 60. I've got to execute those steps to make this particular product at this workstation where I'm working here. And I've even got access to work instructions, to bills of materials, to tooling, to engineering drawings, to all of these different things. And again, this whole example that I just went through from one end to the other is all MES and IoT working together. The next thing I want to talk about here is some AI technology. And I think this AI technology is pretty interesting. I've been working a lot in AI technology in the last 6 months to a year to integrate AI into MES. And I've talked to Chris Monchinsky here about this a bit. And I think that one of the things that Mesa is going to want to do is have a demo of some AI components that are tied in with MES to look at kind of a broad use to kind of answer the question, hey, how do I actually do something with AI? How do I practically take some AI and make it work and do something on the shop floor that helps my manufacturing operation? So stay tuned for that because you're going to see a lot of the stuff that I'm talking about here as part of that demo. And I hope that, Chris, you'll be able to get that demo schedule soon because I'm betting that a lot of our audience today would love to see that demo, that webinar as well. So let's just talk about some of this AI because this is pretty cutting edge stuff that's kind of happening right now, particularly again, integrating AI with MES. So predictive maintenance. This is probably an area that you're most familiar with AI, where you're looking at AI models, particularly typical machine learning type of models, and it could be it could be structured or unstructured learning, but you're looking at machine learning because you're trying to analyze the information about the machine so that you can look at patterns, detect those patterns before anything actually happens so you can plan on your maintenance so you can reduce your downtime, extend your equipment life, and essentially only perform equipment maintenance when you need to perform that maintenance. So that's one use of AI in manufacturing. Another is with quality control, and there are a lot of areas of quality control and QC and QA where AI is helping out. Real-time defect detection with machine vision and deep learning algorithms. I mean, that is something that is on the market right now that is worth taking a look at. Where AI is also being used in a generative AI format to actually generate new testing protocols. So think of a situation where you have a complex product variation excuse me, a complex product variation, and you need to develop a new testing protocol. Perfect for generative AI. Or you get in a situation where you're executing tests and you have some tests that come back with ambiguous results or tests that simply fail. Well, what do I do next? You have AI co-pilots that allow operators to collaboratively work with those co-pilots to then walk through different paths. Okay, if this is ambiguous, we need to do this testing. If this is failed, we need to go do this. If this truly turns out to be a nonconformance, we have to do this dispositioning process. So you have these AI co-pilots that allow the operators to collaboratively work with them and walk them through all of these different scenarios depending on what actually happened when you do these tests. Another area is with SPC. I think everybody knows control charts. Control charts have been around, I don't know, 50 plus years for sure, right? And most everybody loves to not only do standard control charts, but to put pattern rules on those control charts. And the typical pattern rules are like the Western Electric rules. It says if I've got two above or two below or three above or whatever, I make these kind of adjustments, right? But think of that kind of environment with an AI component added to it, where I'm actually taking those patterns and doing my statistical process control with that AI engine behind it. So instead of simple patterns like two above, two below, I've got much more complicated AI analysis going on so I can detect these anomalies long before they occur. And it's just, I mean, it's like SPC and SQC on steroids when I've got this AI engines behind it. Another one is production scheduling and optimization. I think everybody's familiar with our mathematical model based scheduling algorithms, typically finite scheduling kind of algorithms, and how complex those mathematical models are that's behind that drives all that. Well, think of kind of taking it to a level beyond that where I have AI algorithms behind that. So I'm not just using mathematical models, which are um, as complicated as they are. I'm actually taking that to the next level because I'm using some AI models that are even more sophisticated. But more than that, I also have a Gen AI component that I use in conjunction with a co-pilot that allows the operator to collaboratively work, because the number one complaint about any of these mathematical model-based scheduling algorithms is how complicated they are and how difficult they are. It's like you have to have a PhD in the mathematical model just to get the algorithm, the software to do its thing. Having the AI components make the mathematical model more sophisticated, but it also gives you the opportunity to have an AI co-pilot that the operator collaborates with, and so it simplifies everything and makes everything so much easier. So now production scheduling and optimization becomes a reality, and many more people can use it because it can actually be used now and doesn't require that PhD level kind of understanding and knowledge to even get it to work. Supply chain management. This is something that we talk a lot about at Mesa, because the idea of smart manufacturing, where we're optimizing and orchestrating the physical, digital, and business processes inside a manufacturing plant, can be extended across the entire supply chain. So that what we're doing with all this is we're extending it to the entire supply chain and making it a smart supply chain. And again, AI is key to making that happen, because think of how complex your supply chain could be and how many different interactions are possible there, that having this AI component as part of that simply makes a lot of sense. Energy management. Everybody wants to move towards sustainable manufacturing. Okay, we get that. But to be able to do that in real time, I mean, think of all the different places that different energy, waste, um, water, all these different components might be used or generated that could affect sustainable manufacturing. You want to be able to optimize that while still keeping your manufacturing lines running at full capacity. That is pretty complex. Just the amount of data that's required, the amount of data sources that feeds into this. To me, AI is the only way to do this. That you simply can't do it any other way without having an AI tool, just because of the vast amounts of data and the fact that you're trying to do this all in real time to keep everything rolling. All right, so let's switch gears a little bit. We said that this was kind of talking about digital transformation. So we've talked about some cool technologies. We talked about AI. We talked about the track and trace database. We talked about the IoT. We talked about mobility and smart objects and all that. That's all great technology, but what are we actually doing with this and why are we doing this? Well, let's talk about this idea of digital transformation and what we're trying to get out of digital transformation and why it's something that's important. Well, you know, in the post-COVID world that we're living in, there's definitely some things that are changed. Okay, now some of this kind of is probably the same, but some of this seems to have changed, if nothing else, because it's just more intense, it's more accelerated. Okay, the need to get products to market much faster, the fact that I need lower total cost of ownership or lower costs across the board. I've got assets that I've spent millions of dollars on. I've got to get those assets. There's one of the VP of operations told me years ago, you got to sweat the assets. You got to get everything you can out of them. And then you look at the risks that are out there. I mean, cybersecurity being one of the ones that are top of the list, there are some significant challenges that are here. If you think about it, we have ongoing pressures, margin expansion, lower costs, building brand equity, and a lot of manufacturing companies don't have the resources to simply I'm just going to add a bunch of new lines. I'm going to add some new plants. I'm going to hire a new people. Okay, those just aren't options for most people. The bottom line means that you've got to get more out of what you have right now, and the fact that you have the significant global competition means you've got to focus on quality. You've got to focus on product. You've got to focus on productivity. That those are all key challenges that you're facing. The bottom line is that you're still facing this idea of rationalization. How does everybody say it? Okay, well, we need to reduce our excess capacity. We need more responsive plants. We got to move our volume to lower cost locations. Okay, we're going to consolidate by region, by area. I mean, all these are just different ways to say, hey, if we can't do better, we're going to close this place down and do something different. Okay, and that's a key reality even today. Then you look at kind of where manufacturing sits in the overall supply chain, and there's just so many challenges where manufacturing is being pulled in both directions, whether it's supply chain with customer service, unprofitable product mixes, high levels of inventory, rush orders, obsolete or excess materials. I mean, all of these different things are challenges that manufacturing companies are facing, because manufacturing is a key part of the supply chain, sitting right there in the middle of all that. So what's the answer to this digital transformation idea? If we want to transform this, where does MES fit in with this? Well, MES is one of the key tools that's going to help you streamline and optimize your processes. MES is going to be the key tool that is going to allow you to transform manufacturing from reactive to proactive, because it's going to help you increase your speed, your agility, your flexibility, your responsiveness. It's going to increase your ability to collaborate inside your own company, but also collaborate with your suppliers and collaborate with your customers. It's going to help you increase your productivity, your quality, increase your consistency, and your predictability. Those are all real, solid benefits that come from MES as the foundation for digital transformation. So, yeah, let's talk a little bit more about these benefits, and we'll use this as the place to wrap up here today, and then we'll get into some questions. All right. So, one of the key things that you're going to find with MES and with digital transformation is that the benefits aren't going to come from one particular area. they're going to come from synergies between the different areas. If you're trying to justify digital transformation or MES just on, hey, we're going to improve our quality, you probably can't do it. But it's going to be the intersection of quality plus your material plus people, maintenance, data analytics, the track and trace components, the orchestrate, the optimize. It's going to be all of these different pieces together, which is going to make it a reality. And the synergies are going to what is going to add so much value. It's going to be much greater than the sum of all the parts. So it's not just, hey, I can do this and this, but it's the synergies between those supply chain, customers, operations, maintenance, all of those together is where the benefits are going to come from. It's going to be your ability to move from siloed systems and business functions to much broader view of what's going on. Being able to, like it says here, collaborate with my OEMs in real time. Be able to increase my ability to configure my lines and change some of my configurations around. I can't wait months to get to my OEE goals. I need to get to my OEE goals now. I've got some things I've got to do and I need to do them now. My supply chain, I need to know what's going on throughout my supply chain because I've got to make sure my manufacturing plant is a responsive and agile component of that supply chain. That's what I'm trying to achieve. But MES is clear. This is some data that's been compiled from several different places, reducing downtime, improvements in first time quality, lower ramp up anomalies, reduction in maintenance costs. All these are real numbers that have come from real companies that have reported improvements in using MES. Some of the other things to think about: return on invested capital, reducing waste that I've been talking about, improving my quality, reducing my costs, my inventories, my cycle times, shorter time to market, more flexibility, more capabilities, more agility, more responsiveness, better customer satisfaction, fewer stockouts. All of those are real business benefits from this idea of digital transformation, and MES is a key to that. This is some numbers that have come from several different reports that we've compiled. And again, I don't want to go through all these numbers, but simply emphasize that these are real numbers that have been reported by customers in the real world, improving efficiency, yield, asset utilization, reducing labor costs, maintenance costs, energy costs, improving worker productivity, improving first pass quality, eliminating ramp up anomalies. All of these kind of things are real numbers, and you can see the references down here. These are from real reports showing the value of MES. The other thing that I want to mention to you is that us at Rockwell here, we practice what we preach. You may not think of us as a manufacturing company, but we actually have 20 manufacturing plants around the world. And we have implemented MES at all 20 of our manufacturing plants. And we, through MESA and MESA's partnership with LNS, have published these results that we've achieved at our own manufacturing plants by doing these this digital transformation and this MES. Cap reduction and avoid capital avoidance, increasing on-time delivery, increasing yield and quality, reducing lead times, which was huge, reducing our inventory, so that we've had these kinds of impacts to the bottom line. And these are percentage numbers impacting the dollar bottom line of our manufacturing plants. 15% reduction in inventory, 7.8% in responsiveness, 8.6 in financial costs, 17% efficiency improvements, 13.7 quality improvements across all 20 of our manufacturing plants, because we practice what we preach doing this MES and digital transformation. So to wrap up just with a couple of slides, and then we'll get into some questions here. Um, Labor reduction, process variation reduction, raw material variance, better work practices, capital reduction, throughput increases, first pass yield improvements. These are all real benefits that can be achieved. Reducing cycle times, reducing time to market, reducing waste, improving quality, more agility in the supply chain, better command and control, more consistency, increased customer satisfaction, all real benefits. So I want to just leave you with this. Digital transformation and MES isn't the silver bullet. And all that cool technology, even that IoT and AI stuff that we're talking about, is some cool technology, but you can't have technology for technology's sake. The fundamental principle here is you got some smart technology, but you've got some smart people that are using it. So, yeah, I've got technology that gets the right information, the right people at the right time, but those people are highly skilled and highly trained, so they know what all that stuff means, but they're also empowered so that they own the operation, they own their area of the operation, and they make the right decisions. So it's that combination of smart technology, but it's smart people who are using that technology, and those two elements together is what produces your benefits. And that's when it gets real, and the benefits are real, the dollars are real, and the technology's real. So I will leave you with that and simply say thank you for your time. I appreciate it. Let's get into some questions at this point.
John, thank you very much. Appreciate it. Very insightful, well organized. Of course, you're not going to get any argument from me that MES isn't the core and a foundation for digital transformation. Um, but I think you've made some very compelling arguments for why the MES is really a critically important component for manufacturers to have done right in order to streamline and really integrate together all the other sources of data. There are a couple of great questions that were thrown out on the board, so appreciate everyone's attendance and attention, and the questions that are here. So let me get right into it, John, if you're ready. Lev asked this question, and I thought it was a very interesting one. The question is it the right approach to add modules like predictive maintenance and energy monitoring into the MES? Isn't it contradicts, I'll reword it, but isn't it a contradiction with the MES is not the answer to all questions? And you've made that comment a couple of times. Isn't it better to limit system functionality and use a CMMS, for example, for those features? Now, the interesting thing about Lev's question to me is a couple of things to think about. One is that you're absolutely right. I mean, John, you made the point that the MES is not the silver bullet, but the MES also has a lot of important pieces of information and data. There was a time in, let's say, the 90s into early aughts when MES systems were kind of a monolithic system. They had certain features, functions, capabilities. But you made the point, John, of thinking about this from an object-oriented or component-based solution. I think in the mid 21st century now, as we head to 2025 now, we got to think about how we implement MES in any solution differently, as in a more modular approach, and maybe these pieces are part of an MES. What's your thought on that, John?
Yeah, no, I think you're right. I'm thinking of it entirely as functional modules, It's not literally different pieces of some monolithic system or whatever, or you go to one vendor and buy it. Okay. I mean, it's kind of all the above. Different things are going to work for different people. And, energy monitoring can be part of MES, or maybe it's a completely different system, but maybe it's the idea that MES needs to cover all of these functions, whether it's the big monolithic MES or maybe it's 50 different things that you have to get together to do all of that, you know?
You
So
made
I
it, you
think,
made some great,
yeah,
you had some great examples of dashboards in there that were kind of amalgams of all sorts of different sources of data. And I think that's the
right.
world we live in now, where The MES is a critical execution component. It has some of that data and some of those pieces, but it may have to work synergistically with all sorts of other
Right.
systems that are out there
At,
in the ecosystem.
right.
Yeah.
Yeah. And you can tell that I'm thinking of MES as being much bigger than just execution. Okay.
Yeah.
Even though I'll use that MES or some people like MOM for manufacturing operations management, MES MOM,
Mhm.
whatever. I think of MES as being much, much greater than just execution. I mean, it's basically everything that I've talked about here today. Even the AI and the IoT components are part of MES in my world. I mean, it's all
Yeah.
part of it because it's all required to support operations on the shop floor. And
Excellent.
some people even get this thing going where, well, if I have the IoT, then I don't need MES, or if I get MES, I don't need the IoT. It's like, wait a second, you
No.
know, you need them both because they probably do different things, but who said there it's either or? It's like, why not? All of everything that I do has IoT as part of MES, which is part of the bigger solution. Okay, so it's all the above. So Lev, I don't know if we've answered your question completely, but hopefully you're kind of getting a feel for you know for for
Yeah.
for for where we're coming from here, what we're trying to say.
Excellent. Thank you. So there's a bunch of questions that are coming in. So let me grab one from AJ here. Um, he had mentioned, of course, first of all, he thanked everyone here for a great session. So thank you, John, again for a great session, very informative. But he had asked about the use of industrial co-pilots and use cases and examples to share.
Oh,
And I thought
yeah.
this was you had kind of had a whole tangent about AI, and I know you started to talk about how AI technologies can augment existing systems. I kind of think of that as the co-pilot example. Maybe you can elaborate on that a little further for AJ.
Yeah, yeah. So I think there's lots of co-pilot use cases that we can come up with. Let me just throw a few of them out here, and let me be careful on time. I could probably go 20 or 30 minutes minimum
Don't do
just
that.
on AI,
But
just on AI co-pilots, right? So let me just throw a couple of them out. So we talked about the AI co-pilot that might be used in quality. Okay, we talked about an AI co-pilot that could be used in scheduling. All right, I could use an AI co-pilot to do error proofing. So let's say I'm making a batch, okay, and I've got some very specific steps that I have to perform in a very specific way, and those steps have to be error proofed. Okay, I just can't perform those willy nilly. I can't make a mistake. They have to be done right if I make a mistake. So I'm going to use a co pilot that's going to walk me through that. I'm going to work collaboratively with that co pilot to go through all of that to make sure I completely error proof all of my steps. That's especially true if I end up with a situation where I have a non-conformance. So now I have to go deal with a non-conformance. Maybe I have to do a rework. Maybe I have to go get dispositioning. I have to go do retesting or something like that. Okay, so that's another example of a co-pilot. A couple of other things that where our co-pilots are used is I have a situation where I've got at the I'm running a 24/7 operation, and so I have a very limited amount of time to do a shift handover. Okay, so what I need is an AI co-pilot that's going to walk me through everything that happened on the last shift and the key things that I need to be the open issues that I need to be worried about right now for my shift, as well as the things that may occur during my shift that that I need to be looking out for. So that's kind of another example of a co-pilot. Um, kitting for some industries. I mean, we do a lot of stuff with pharmaceuticals, med devices, things like that. We're producing kits are very critical. You're going to mess the whole product up. So having an AI co-pilot that's going to walk you through how to assemble a kit to make sure I've got the right products, I've got the right lot numbers, I got the right materials, I got the right material variations. That all of that is another great example. And I'll leave you with one last example of an AI co-pilot has to do with the work instructions. Okay, so and this is a great area for also Gen AI that we're doing a lot of work in is you think of these work instructions. Oh, I got all these work instructions. I got these manuals. I've got these procedures. I've got these SOPs. I've got these engineering drawings. I've got all this stuff. And it's like if I'm supposed to read all this stuff, I'll never do my job because I'll spend the whole shift just reading this material. So I get an AI co-pilot to ingest all of that material and then simply walk me through the relevant parts to make sure I get it right. So if I need a work instruction, the AI Copilot takes me and shows me just that piece that I need, shows me that piece, whatever it is. And so all of that massive amount of paperwork that I'm supposed to be familiar with, but there's no way any human being, because if you look at all the different products companies make, all the different variations, and the fact that they're introducing new products and new variations, I mean, it's like new revs of products, new revs of engineering drawings are like released every day. How is an operator or hundreds of operators on a shop floor even supposed to keep up with all of that? Okay, that's where you need a MES. That's where you need AI. That's where you need an AI co-pilot and the AI Copilot. So just so hopefully that answers that question of several different AI Copilot examples. I got a dozen
Yeah.
more,
I was
but
to say there's a great set of
yeah,
examples, and I know
yeah,
there's more. Absolutely.
yeah,
Um, there's a couple more questions. I think we have a couple more minutes, so I'd love to get through them here. Syed asks us if we could quote some examples of how people were engaged for successful implementations of MES. So maybe a question about culture change, people integration, connected worker, all sorts of different
yeah.
directions you can go in there.
Yeah, Chris. Yeah, I mean, you hit the nail on the head, and you can answer this question as easy as I can because all that's important. I mean, look, the people are the key part of the equation. I mean, I said several times in the presentation, yeah, it's smart technology, but it's smart technology and smart people. Okay, um, and so the people have to be part of the equation because the people have to use the system. Because people, people will think you might think that, well, hey, my from an engineering point of view, the project is over when I've implemented the system and I've tested it and I've walked away and said, yep, it's running, it's all good, have at it, the project's done, and I walk away and I go as an engineer to my next project. Okay, but for the people on the shop floor, the project just started because for them, what's the project? The project isn't all this engineering stuff that has to be done. The project is I'm supposed to use this new thing, this AI, this MES, this whatever it is. I'm supposed to use this new thing to do things better on the shop floor. So for them, the project starts when the system gets delivered. So getting them on board to understand that, supporting the people side of that project, so making sure that they're successful is way more important because look, let me say it differently. The technology's out there, the technology works, okay? All right, sure, some of it's complicated, some of it's pretty cool, some of it's whatever, but it all works. If a project fails, it's going to be because of the people on the shop floor. It's like, oh, I don't understand how to use this. I don't understand what it's supposed to be doing. Why did this guy just deliver this and walk away? I can't even get him to answer any questions. Okay, I haven't been trained on this. I don't know how to do any of this. So focusing on the people side of the the equation is far more valuable and far more critical than any other aspect. And that's what's going to make and break it. So whether it's training, it's change management, it's support, it's retraining, it's communications, it's just, I mean, just being there with the people to make sure that they get it and make sure they adopt it. That's what is critical to success. And that's why I was saying that the only way you're going to get the success is, yeah, you got to have this smart technology, but you got to have some smart people who are using it to the max and getting out of it what they need to get out of it. And the people side of the equation is just as important, if not more important, than anything else.
Great. Well said, and I agree with you 100%. I've seen many a system be slow adopted or be used incorrectly because of either poor training or a rejection by operations that the software is and the solution is either cumbersome or redundant or you can to pick your criticism, right? Exactly. But definitely integrating the people, the end user, your end user in the loop. And getting their input on how the system should work to benefit them is critically important. Couple more. Debrisa asks a question, which I think is kind of interesting. You may have an opinion on this. I know I do. I'll paraphrase a little bit here, but there are all the MES softwares that are out there today. Are they all more or less the same in terms of functionality? In the way, for example, most CAD systems now will do most of the things that you need to do in the CAD environment. Or are there specific features that stand out? So, for example, should the focus in selecting an MES be more on how it integrates upstream and downstream, integration being critically important? Or are there specific features in an MES that you should be looking for, depending upon maybe industry or use, etc.?
Okay, wow, there's a lot in that. A lot to
Yes.
unpack in that one. Okay. All right. So first of all, absolutely, absolutely no. They are not the same.
Excellent.
They are absolutely not the same. They are widely different. And a lot of the vendors will try to tell you that they all do everything, okay? But they're the vendors. They're trying to sell you something. So beware of the vendor trying to sell you something, okay? They're not all the same. They don't all work the same, okay? And for the most part, they're all different in the way they approach the product and the requirements and the way they approach their particular industries. You'll find several different things. One is you'll have some that are work well in certain industries that don't work well in others, okay? There's a big difference between process and discrete, but there's also very specific requirements for companies like in pharmaceutical, in med devices, for food, bev, and CPG. There's other requirements in automotive, tire, EV batteries. There's other requirements in like electronics, electronic manufacturing, in chemicals, which is back over in process. I mean, all of these are vastly different, okay? And they range from fundamentals like in this, I need to track everything by a kilo, but over here, I track everything by an each. That's process versus discrete. That's at a base level. But then you just go throughout the entire MES, and they are very very different. So you need to look at what's going to be best for you, what's going to be best for your industry. Okay. You also need to look at the way the MES works. They range from sort of a toolkit on one end of the spectrum that says, you just kind of have to put it together, but it's got a lot of components, to stuff that's just out of the box and it just works, but that's kind of what you get is what you get, and you can't get anything different, you know. The other thing that the question is asking about, I think, is how it integrates to upstream and downstream. Some MES, like we said before, are trying to be all things to all people, this big monolithic whatever. Other MES is trying to be, hey, I can integrate with PLM, with CMMS, to ERP, to DCS, with LMS, with QMS, they take that kind of approach. They live in a world where there's lots of other systems out there that they need to be a part of and live in that kind of environment. Okay. So the answer is no, they're not all the same. They're vastly different. Beware of the salespeople. Look closely in what works. Find the one that works for you. Um, Look at options to do pilot projects. Don't just take a demo from a vendor and say, well, oh boy, this demo looks good. Do some pilot projects, do some of your own things, and beware of price, because there's a wide range of prices that are out there. But when it comes to MES, I will tell you this: you're going to get what you pay for. That cheap is probably not going to be good, and good is probably not going to be cheap. Okay, which kind of gets into maybe the last question, or one of the last questions that I noticed pop up here, which is from Lane about about justification. Okay, the good news about justification is that it's justifying MES at some level is pretty hard, because you do a lot of work and you're basically saying, if we could get this MES, we could do all of this. And people are just going to be skeptical. They're like going to be, I'm going to spend 1 million, 2 million, I don't know what, some other big number, 500,000 on an MES system. And you're just going to tell me I'm magically going to get all of these different things. So when it comes to justification, one of the things that I like to do with my clients is be able to sit down and map out exactly what the MES is going to do, exactly what the people are going to do with the MES, and exactly how that is going to translate into benefits. So I'll often start with their pain points. Okay, we're having this pain. This is what MES is going to do to address that pain. This is how the people work with the MES. And then this is what the result is going to be because we're now going to do this and this and this better. And doing this and this and this better gets me this kind of financial improvement. So it's a very, very detailed exercise to go through to do the justification. It requires some people from your company that are familiar with financing, okay, that are on board with what you're trying to do because everybody's going to trust the finance people more than some engineering person when it comes to a number with a dollar sign in front of it, okay? But the bottom line, and I'll leave you with this, Chris, because I think we're just about out of time.
Yep.
MES can easily be justified. And all of the MES systems that I've seen have actually generated 2, 3, 5, 10 times the benefits that they were originally projected because of all the synergies that happen and because they can build success on top of success on top of success. And it becomes such a platform and such a foundation to do all kinds of things that they never even thought of, that having 3, 5, and 10 times the benefits from an MES system is real.
Yeah,
And
I'm glad that you grabbed Lane's question too, because I was going to say that in that question, I thought was kind of interesting is that you may, for those of you who are part of Mesa, or even if you've heard from some of the Mesa's recent um, publications and blasts out on LinkedIn, John Clemens helped lead up a group that contributed to the revision of an ROI guidebook for smart manufacturing and the implementation of technologies like MES. It's a newly published guidebook. It is a guidebook that existed in a different form. It's been revised all the way back in 2014. So it's got a lot of history to it, but it's nice and fresh and new. And as John pointed out, it has years of experience from him and others who've contributed into that guidebook on how to justify MES, what works, how to bring the collective of people together within your organization to put some real numbers out there that people will believe in, and to be able to measure up to those numbers when you actually implement that MES. So those, after it's all said and done, you want to be able to demonstrate those things too. And as John pointed out, there's some great stories to tell. Um, we are at the hour. So first of all, I appreciate everybody who joined us today and gave us an hour of your time. An hour is valuable for all of us, so we definitely appreciate that. I want to say thank you very much for John Clemens for a terrifically engaging discussion. Lots of great questions. The heart and soul of what we do here at Mesa. And I think, John, you boiled it down to a very digestible set of content that we can all take something away from here. So thank you very much.
And hey, I just want to say thank you to everybody that's part of our presentation today. Thank you so much for your time. I really appreciate you being on the webinar here. Again, you get copies of the recording, you get copies of the material. So thank you so much. We really appreciate you being with us here today.
All right. We're at the hour. Thank you very much. Appreciate it.